Good evening, and welcome to another episode of Maths in an Empty Classroom with me, Mr. Southern. This is the second lesson on non-constant acceleration, the kinematics topic from mechanics, and this evening we're going to look at a slightly different example where you get different original information and have to work things out from there. So, here we have a particle is moving on the x-axis. At time t equals 0, the particle has a displacement of 5 metres from a fixed origin O. I've just written that down here, that when t equals 0, x equals 5. And remember, in this case, we're using x to represent displacement. So that's important here. Sometimes we use s. In this context, we're using x. X is displacement. We're told that the velocity of the particle at time t seconds is v equals 6t minus t squared. So this is a formula for velocity. So the acceleration is non-constant. Remember, that means we can't use SUVAT. We've got to use calculus. So all the work we're going to do this evening is going to involve differentiation and integration. Part A is asking us for the acceleration of the particle when t equals 0.5. So if I know velocity and I want acceleration, I need to differentiate. And I differentiate because acceleration is the rate of change of velocity. And remember, I say whenever you hear about rate, we think differentiate. So differentiate this, and we're going to get 6 minus 2t. We're asked for the acceleration when t equals 0.5. So we substitute 0.5 into this expression for acceleration, which gives us an acceleration of 5, and the unit is ms to the minus 2, metres per second per second. Part B is asking us for the acceleration when t equals 4. So when t equals 4, we sub in 4 to our expression for acceleration, and we get negative 2. So what that means is at this point in time, the particle is actually decelerating. So it has a deceleration of minus 2. We've been asked for the acceleration, so we just state it as negative 2 ms to the minus 2. So a deceleration there. Now, for part C, the greatest speed of the particle in the interval. To enable me to do this one, I am actually going to do a sketch of the graph for velocity. So I've got my time axis here, my velocity axis here, and I'm going to use the information that I have about this equation here, v equals 6t minus t squared, to sketch the curve. So what I'm actually going to do is, instead of writing it as 6t minus t squared, I'm going to write it as t bracket 6 minus t, because that shows me that the roots of this equation are t equals 0 and t equals 6. Now what that means is that the graph is going to cross the x-axis, but it's t-axis here for time, at 0 and 6. It is a quadratic because it's squared and it's negative, therefore what it's going to look like is a graph like that there. And I've just sketched it for the interval 0 to 6 because that is the time that I've been told in the question that this model is valid for. T is greater than 0. Now let's just review our answers to part A and part B in the context of this graph. Now part A, the acceleration when t is 0.5, if I place my ruler on the curve here and I look at the tangent, the rate of change, I can see that I've got quite a steep positive gradient here. That gradient would be 5 because it's the acceleration at that point, it's the rate of change of velocity. Now 0, 6, the midpoint here is going to be when t is 3. So when t is 4, I'm past 3, and as you can see there, if I were to draw a tangent in when t is 4, that tangent has a negative gradient because at this point the particle is decelerating, and that's why I got negative 2 as my answer for B. So drawing a sketch is really, really helpful to enable you to interpret what's going on in these non-constant acceleration questions. Okay, now I'm asked for the greatest speed. Now, the greatest speed is going to be this maximum turning point here. Now, I can see that that's going to be t equals 3 because I've got a quadratic with roots 0 and 6, and I can see that it's midway through. What you could also do to find that is when the rate of change of velocity is 0, when the acceleration is 0, that is going to be the greatest velocity. That's when the turning point is going to happen. And you can see that if I solve 6 minus 2t equals 0, I'm going to get t equals 3 from that equation there, which is this time point here. So I'm asked for the greatest speed of the particle in that interval from 0 to 6. So to get that, I need to substitute t equals 3 into my equation for velocity. So my velocity is 6 times 3 minus 3 squared, substituting 3 in for t, and that comes out as 9 meters per second, 9 ms to the minus 1. That is my greatest speed in this interval. So that coordinate there on that graph would be 3, 9. And as you can see, that is the turning point when the acceleration is 0. At that point we have maximum velocity. So all links in with what we know about calculus, turning points, tangents, all those things have been explored here. Join me in part 2 of this video where I'll finish off the question parts D, E and F.